Hello everyone, welcome back to my channel. In today's session, I'll be explaining QuickSort algorithm. Please don't forget to like and subscribe this channel so that you don't miss out on any upcoming sessions. QuickSort is an in-place sorting algorithm and is based on the divide and conquer principle. This algorithm finds a pivot element in each iteration. In the process of finding the pivot element, we are partitioning the array in such a way that the pivot element must be in the correct position in the array and all the elements left to the pivot element must be smaller than it and all the elements to the right must be greater. The worst case complexity of quicksort algorithm is big O n square, whereas the best case is big O of n log n. Now, I have mentioned about the partitioning. So basically, quicksort algorithm has two components. One is the partition and one is the quicksort algorithm. Let's first understand this partitioning method. So in the partitioning method, we provide three inputs, that is the array itself, then the start, and then the end. We initialize the pivot element as the last element of the array by array of end. We initialize a variable I as start minus 1 and then we loop the entire array from start till n minus 1, and the moment we check for each and every element, we compare every element with the pivot element. If the current element is less than the pivot element, then we increment the I counter and swap array of I and array of j. So with this, the for loop ends. So we have just iterated the loop once and compare each and every element with the pivot element. Once you exit the loop, we again increment the I counter and then swap array of I and the pivot element. Pivot element is nothing but the array of end. And in the end, we return I. I is basically the index of the pivot element. After this partitioning, the pivot element must be in the correct position at the point at the index I. Now let's see how the quicksort algorithm works. Basically, this is the driver function for the partitioning. So there always has to be a base condition. We say that if start exceeds the end index, then just return it. And if not, then what we do is we first find the pivot element. How? By calling the partition function. We first call the partition function. Now we have the index of the pivot element. So we will recursively call the quicksort algorithm from start till pivot minus 1 and from pivot plus 1 to end, because pivot element is already in the sorted condition. Let's see this with an example. Let's say this is an array 10, 5, 6, 4 and 7. So we start with 7 as the pivot element. So the input to the partition function would be start as 0 and would be 4. We will be initializing I as minus 1 and looping from 0 to 3 index. So how it will happen? First we will compare 10 with 7. Is 10 less than 7? No. Then we will compare 5 with 7. Yes, it is less than. And your I was what? Minus 1. So we will swap array of I and array of j, which means array of 0 and array of 1. So 5 and 10 will be swapped. Then j is now at 2, which means value equal to 6. So we will compare both 6 and 7. Yes, 6 is less than 7. So what we are gonna do is again swap array of I and array of j. Before that we'll increment I. This time we will be swapping 10 and 6 because at array of 1, 10 is already there. In the first swap that has occurred. Then again we will compare 4 and 7, and so we will again swap 4 and 10. So what will happen is basically 10 has reached at array of 3 and 5, 6 and 4 have moved one left, 7, and in the end after we exit the for loop we are going to swap array of I and array of j. Before that we increment again I. So in that case we will be swapping array of 3 and array of 4. So 7 and 10 will be swapped. 10 would be in the rightmost and 7 would be in the correct position. After the first iteration, this is how the array would look like: 5, 6, 4, 7 and 10. Now we will again do the partitioning on the left and the right of the pivot elements. So for right, start is 4 and end is 4, so it will simply return. When we do check the condition, if start is less than n, it will simply return, so no need to sort on that part. On the left hand part, let's see how it will work. So start would be 0, so the position of pivot is what, 3. So we will the input to the partitioning function would be 0 to pivot minus 1, that would be like 2. I would again be minus 1, and we will be looping from j equal to 0 to 1. So we will check, is 5 less than 4? No. 6 less than 4? No. So we will just exit the for loop, and we will do an I plus plus, so I would be 0, and swap these two, array of end and array of I. So 4 will come in the beginning, then it would be 6, and then it would be 5. Now after this, 4 is also in the sorted position. Let's see how the further it will work. So now we will choose 5 as the pivot element. The input to the partitioning function would be start as 1, end as 2. Now I would be equal to start minus 1, so it is 0, and we will iterate from 1 to 1. Basically there's just one element to check. So we check, is 6 less than 5? No, it is not. So we just exit the for loop, and after that we increment the value of I, so I equals to 1 now, and we will swap both 5 and 6. So after this, the array would be sorted. How it will be look like is 4, 5, 6, 7, and 10. Thank you for taking a look.